Hey, we're looking at related rate problems. We've got, this happens to be a right circular cone. So we're looking at the radius r of a cone and it's increasing at a rate of 12 meters per second. The cone's radius is 3 times the height. So I know, Rod, boy, I can remember when I was learning this stuff for the first time. That just blew my mind right there. Anyway, I'll try to hopefully clear that up. But anyway, it says, what is the rate of change of the volume when R is equal to 10 meters? So the rate of change of volume, so we're looking at dV over dt. That's what we want to find. And then, of course, we've got another problem here, but we're going to look at that here in just a minute. I'm not going to read that. So anyway, so we're looking at, we're wanting to find dV over dt. We're given R, which is 10, and we're given dr over dt, which is 12 meters per second. So let's go find dV over dt. Well, we're going to need to know the formula for finding the volume of a right circular cone, and this happens to be it right here. Pi r squared times h over 3. I guess I should have a picture of a cone, but I think everybody should know what a cone looks like, right? It's got the height and the radius there at the bottom. But anyway, now they gave us a relationship. They said that the radius was 3 times the height. So what you need to do is you need to write this out. The radius is, and is equals here, 3 times the height. And then what we're going to do is we're going to go ahead and get this thing all in terms of r. Right, so we're going to replace this h and get everything in terms of r here. And so we go ahead and solve for h in this problem. So h is equal to r over 3. And then we take this r over 3 and plug it into the r right here, as you can see. All right. And then, of course, we need to simplify this down as much as we can. We have r squared times r, which is r cubed. So I have 1/3. Take that down into the bottom, and there it is. We have pi r cubed over 9. So now what we're going to do is we're going to take the derivative. So we got dV over dt is equal to, bring the 3 out front, pi r squared over 9 times, remember we tack on a dr over dt because that's what we're taking the derivative of. And then, of course, we want to simplify this down as much as we can. We end up with pi r squared over 3 times the dr over dt. And then what we're going to do is just go ahead and plug everything in that they give us, right? So they gave us r, which was 10, and the dr over dt, which was 12. And then we need to simplify that down. And we end up with dV over dt is 400 pi m cubic meters per second.